Can you believe it? A 70-year-old man is about to pull off something everyone thinks is impossible. No construction crew, no heavy machinery, no professional blueprints, yet he insists on building a Japanese dome house entirely by hand. The roof's compression ring is assembled with millimeter precision, and everything from moisture-proofing to insulation to the skylight is handcrafted. Costs drop by 90%, and the craftsmanship outperforms professional teams. This isn't just building a house, it's a 70-year-old man creating an architectural miracle with his own hands. He knelt on the grass, fixed the center with a hemp rope, and slowly widened the radius. With a slight twist of his wrist, a perfect circle appears on the ground. This is the lifeline of a Japanese dome, the center point layout. What he's taking on is the Bochi hut, widely considered one of the hardest dome structures in architecture. Everyone thinks he's joking with his own old age. The fatal flaw of circular structures is symmetry error at the center. If the error exceeds 0.5 millimeters, the entire roof could collapse. Even young craftsmen with laser tools struggle to reach that level of precision. The circle he drew by hand has an error of just 0.2 millimeters. This barren grassy slope has no water, no electricity, no paved roads, no construction conditions at all. In modern construction, building a round house requires laser positioning tools, total stations, and a full professional crew. At 70, with zero equipment, he takes on the hardest construction challenge alone. After digging 30 centimeters down the foundation, a piece of granite bedrock was found, positioned precisely at the center of the circle. The rock disrupts the level base, blocks load transfer, and prevents the foundation from being secured. He first fed the crushed stone aggregate into the mixer, where it was thoroughly mixed with cement to produce high-strength concrete. In the pre-excavated foundation pit, a well-mixed cement aggregate mixture is poured in to solidify the initial load-bearing framework of the foundation. To create neat and orderly cement pillars, he used locally sourced materials, selecting rigid paper tubes as molds. He precisely cut and shaped them according to the load-bearing dimensions, and then slowly poured the cement aggregate mixture into the mold cavity. The foundation pit was compacted and leveled using traditional, purely manual methods by the elderly man. First, the bottom of the pit is filled with crushed stone aggregate, and then repeatedly tamped and compacted with a foot-operated wooden mallet to prevent later settlement. Lay the first layer of cement leveling layer, and smoothly embed 2 steel bars as reinforcing bars. Then cover with the second layer of cement, and continue to embed 2 steel bars to reinforce the structure. Finally, completely seal with cement, smooth the surface, and let it stand to wait for the cement to dry and cure completely. After the cement base has solidified to the required standard, he precisely placed the prefabricated cement column into the center of the foundation pit and filled, covered, and sealed it with cement to form a base support column with full load-bearing capacity. A fixed solid wood column is inserted into the center of the pillar, serving as the core load-bearing component connecting the circular base above. The base of the entire Japanese-style domed house adopts an inner and outer double ring-grated load-bearing structure. The outer ring of cement base is entirely supported by cement columns cast from paper tube molds. The inner ring of wooden base consists of small cement columns and solid wood connecting rods working together to support the load. With double ring force distribution and bidirectional support, the circular base experiences more even stress and has a more stable structure, laying a solid foundation for the entire building that will never collapse. With the foundation cleared, he moves straight to building the wooden base. This isn't just a floor, it's the load-bearing core of the house. He selected high-density, anti-corrosion solid wood. The entire frame uses traditional mortise and tenon joints. The joints fit so tight not even paper can slip through. Each wall panel is equipped with 3 fixing points to ensure that the wall and the base are firmly locked together, without displacement or shaking. The compression ring is the structural spine of the dome. Industry standard, error must be 0.3 mm. He achieves 0.1 mm. With more than half of the wall panels already assembled, the elderly man uses a homemade vertical ruler to constantly check the verticality of the wall, keeping the tilt error within 1 mm. To adapt to the curved structure of the circular building, he handcrafted flat boards into standard curved wall panels, ensuring that each panel had a uniform height and a curvature that perfectly matched the outer contour. All wall panel edges are pre-treated with tongue and groove joints to ensure seamless fitting and interlocking during splicing, forming a ring-shaped enclosure structure that bears the overall load. A 3 cm thick extruded polystyrene insulation board is laid at the bottom of the frame to block the upward conduction of underground moisture and low temperatures. The gaps in the insulation board are filled with sealant to prevent the penetration of hot and cold air and improve the overall thermal insulation efficiency. An 18 mm thick waterproof plywood is laid on top of the insulation board as the floor base. A 2 mm expansion joint is left at the joints of the plywood to prevent the board surface from warping due to thermal expansion and contraction. With the base and compression rings completed, construction has entered the wall assembly stage. He employed a ring-shaped modular wall structure, with each panel weighing 28 kilograms. Each panel must be securely locked to the base and tightly interlocked with adjacent panels. This ring-shaped structure provides 3 times the uniformity of stress distribution compared to a typical square wall. He added a ring of horizontal reinforcing timber to the upper part of the wall, fixing it evenly along the inner wall of the ring, connecting the independent wall panels into an inseparable whole. When the last panel was installed, the entire wall was a single, seamless structure. Even when an adult man rammed it with all his might, the wall remained completely still, as stable as a rock. He precisely marked the dimensions of doors and windows at the predetermined locations on the wall, and smoothly cut out square openings with a hand saw. He then added a solid wood reinforcement frame around the openings to prevent the wall from cracking or deforming under stress. With the structural framework in place, he began to create a marvel of natural light, a hemispherical skylight dome. A transparent plastic hemispherical skylight is installed at the top of the compression ring. This design allows natural light to flood the interior 360 degrees, eliminating the need for artificial lighting during the day. Next, he began laying the roof tiles. A circular roof cannot be tiled in a straight line. A fan-shaped arrangement must be used. The interior of the roof is filled with fiberglass insulation material. This is a material with low thermal conductivity, essentially giving the house a temperature-regulating outer layer. It blocks outdoor heat in summer and locks in indoor temperature in winter, maintaining a constant temperature all year round. A dome skylight and fan-shaped tiles boost drainage by 30%. Next, he began laying the roof tiles. A circular roof cannot be tiled in a straight line. A fan-shaped arrangement must be used. He personally cut each tile, overlapping them in a fan shape to perfectly fit the curve. This method of laying tiles results in 30% higher drainage efficiency than ordinary tiles, ensuring no water accumulation even during heavy rain. He created rainwater drainage extensions for the windows, completely eliminating leakage at the window seams. For the water supply system, he chose flexible PEX pipes. These pipes are frost-resistant, corrosion-resistant, and can be bent freely, perfectly adapting to irregular circular layouts. No complicated pipe fittings or adapters are needed, and no cutting or rerouting is required. Installation can be completed in one step. The cooking area is of paramount importance for home safety. He reinforced the base of the burner to withstand high temperatures and daily weight. The chimney is precisely positioned, with a deviation of no more than 1 centimeter, and a specialized fireproof and heat-insulating structure is constructed. This completely eliminates fire hazards and safeguards the bottom line of residential safety. Finally, he installed mosquito netting on the entrance door, achieving both ventilation and insect control, from waterproofing, insulation, and plumbing to fireproofing, insect control, and load-bearing capacity. A 70-year-old man took on all the jobs without missing a single one. In this era that relies on machinery, worships speed, and seeks shortcuts, this 70-year-old man, in the most clumsy, purest, and most persistent way, completed a groundbreaking act of defiance that has shaken the architectural world. 70 years old is never the end of life. It's a brand new beginning for passion and dreams. As long as you don't accept your fate, don't give up, and don't compromise. Ordinary people can also create extraordinary legends that shake the world. As long as there is passion in your heart and skill in your hands, you can still become a legend at 70. If you'd like to learn more about the complete construction details and techniques, you can subscribe to the Original Video Creators YouTube channel to unlock more handcrafted construction content.